First question, the IUPAC name of given compound is. So the first rule of an IUPAC is to select the longest carbon chain. And this 1, 2, 3, 4, 5, 6 and 7 carbon chain is the longest carbon chain. So thus the parent name we got is heptane. Now we can see there is one alkyne group present here and there is one alkene group present over here with one chlorine branch, one methyl branch and one ethyl branch. Okay, now the numbering starts from this side, giving priority to alkyne group. It starts from here 1, 2, 3, 4, 5, 6 and 7. So this 7 carbons. Now there is one position पे alkyne, then there is fifth पे there is an alkene, sixth there is a chloro group, fifth methyl and fourth ethyl. Now according to alphabetical order, chlorine comes first, so we are supposed to write 6 chloro. Then among methyl and ethyl, E comes first, so then we have at 4 ethyl position, ethyl group. Then at 5 we have methyl molecule. Okay, then there's a parent chain where 2 more functional group are present. So we are supposed to write hept 5-ene and 1-ine. Okay, so last ANE is replaced by 5-ENE and that E is replaced by YNE. So now looking towards the option, if we have the similar thing, 6 chloro starts in option A and B both. Then 4th ethyl also. Then 5th methyl is also there. Now there is a difference in the numbering of ene and ine. So we have ene at 5th position. Therefore, correct answer for this question is option A. That is 6 chloro, 4 ethyl, 5 methyl, hept, 5-ene, 1-ine. Looking towards the next question. Which of the following compound may not exist as enantiomers? So enantiomers are a pair of molecules which are mirror images, non-superimposable mirror images of each other. And a very necessary condition for enantiomers is a chiral carbon. Chiral carbon is a carbon where all the valencies, all the 4 valencies are satisfied with different molecule or different group. Now, if you look here, that is CH3CHOH, then COOH. So if you look at this molecule, it's a mirror image. So chiral carbon, that is this CH3 attached with CH, OH and COOH. So we can form the mirror image which have COH, CH, OH and CH3, and thus it is a thus it is a mirror image of each other and thus it can form enantiomers. If we look at this molecule, this is also similar to this only. At one side we have CH3, CH2, C with H and the CH3, and on this side we have CH2OH. So this is also having a chiral carbon and thus we can form a mirror image. So this can also form an enantiomer. Looking towards the option C, it is having one side C6H5 attached with C and 2H with the CH3. So this is not a chiral carbon because 2 valencies are similar. There are 2 hydrogen atoms. So this is a molecule which does not contain a chiral carbon and cannot form enantiomers. Here in this D option also we have a chiral carbon. I'll show you, that is C6H5 attached with a carbon where one H is attached, one Cl is there and one CH3. So this is also a chiral carbon and it can also form enantiomer. The compound which does not form enantiomer is only option C because it does not contain a chiral carbon. So correct answer for this question is option C. Looking towards the next question. maximum number of isomers of alkene C4H8. So we know C4H8 is butene. So butene can have CH3, CH2, CH double bond CH2. Okay, one butene. Then it can form CH3, CH double bond CH, CH3. 2-butene, but this 2-butene is possible in two different forms. So this can be in two different forms. One is the trans and other is the cis. So that is, if both the CH3 are on the same side and H on the same side, it is cis, and if CH3 are there on the opposite side, it is trans. Okay, so this is 1-butene and these two are the structures for 2-butene. Now this same molecular formula goes for a cyclobutane, that is CH2, CH2, CH2 and this CH2. So there are C4 and H8. Cyclobutane is also possible. We can also have three carbon का cycle chain with one branch of CH3. So here we can have CH, CH2 and CH2. Count the carbons. There are 4 carbons. 3 plus 1, 4. 5, 6, 7, 8. So this also have the same molecular formula. And also in the case of alkene, we can form 3 carbons ka straight chain with an alkene group with one branch of CH3. So this is also 4 carbons with 3, 3, 6 and 7, 8. 8 carbons. So this is the first structure, second structure, third structure, fourth, fifth and sixth. That means there are 6 number of possible isomers. So 6 is there in option D. So correct answer for this question is option D. Looking towards the next question. Which of the following will have meso-isomer also? So meso-isomer is a molecule where you can cut the molecule in 2 equal half and they form their each other's mirror image. I'll show you. So first it is 2,3 dichloropentane. So let's draw pentane. 5 carbons, straight chain. Okay, this is CH3, CH3, and there are 2,3 chloro. So 1 chlorine at the second carbon and 1 chlorine at the third carbon. Okay, and there are 2 hydrogens here. So if you look here, this molecule cannot be cut into 2 equal halves, and thus this is not a mesoisomer. If you look at the next, that is 2,3 dichlorobutane. So if I cut this, CH3, C, C and CH3, and there are 2,3 dichlorobutane. So if I cut this molecule from this plane, I can have 2 equal mirror images, and this molecule is called to be have mesoisomer. So correct answer for this question is option B, that is 2,3 dichlorobutane. It has mesoisomer. Looking towards the last question. Which of the following compound have wrong IUPAC name? So the first molecule, there are 4 carbon ester group and there's a branch. So this is ethyl and this is butane with an ester group. So it is ethyl butanoate. It is absolutely correct IUPAC name. Okay, next if you look, so this is an aldehyde carbon. So 1, 2, 3 and 4, and there is one branch at third position. So 3-methyl butanal. So this is also a correct IUPAC name given. Then if you look at the next molecule and give the numbering from this side, it is 1, 2, 3, 4, because here the OH group is attached. So the priority is given to the functional group, and thus the numbering from this side is essential. So it is 2-hydroxy, or basically 3-methyl butane 2-ol. So this is given reverse. Here it should come 3-methyl and 2-butanol. So this is not a correct IUPAC name. And thus the correct answer for this question is option C.